Hello everyone. Today I tell you about the next article, New Insights into the Prediction for the Potential of Soil Organic Carbon Accumulation from the Perspective of Non-Equilibrium Statistical Machines. Soil organic carbon is an essential component of healthy soils because it improves soil fertility, supports plant growth, increases crop production, and helps reduce climate change by storing carbon in the soil. The amount of soil organic carbon depends largely on the activity of soil microorganisms, especially on their carbon use efficiency, which describes how efficiently microorganisms use carbon to produce new biomass instead of releasing into respiration. Although many previous studies have investigated the relationship between carbon use efficiency and soil organic carbon, most of them used equilibrium models. These models assume that soil systems remain stable over time and don't fully consider the continuous environmental change that affect microbial communities. To overcome this limitation, the authors develop a new framework based on non-equilibrium statistical mechanics. This approach includes stochastic environmental fluctuations and allows the study of microbial systems under changing conditions. The model combines carbon use efficiency and soil organic carbon dynamics and environmental factors to explain how soils move between two different states, carbon loss and carbon sequestration. The research also used potential landscapes and probability distribution to describe the stability of these states and the transition between them. Using global soil data, the study identified nitrogen as the most important environmental factor influencing microbial carbon use efficiency. As nitrogen levels increase, microorganisms use carbon more efficiently for biomass production, making the carbon sequestration state more stable than the carbon loss state. The analysis also showed that environmental disturbance can temporarily change the carbon state, demonstrating that soil carbon dynamics are strongly influenced by random fluctuations as well as by nitrogen availability. One of the most important findings of the study is the identification of an early prediction signal at approximately 0.5 of nitrogen. At this level, soils begin to show the potential to transition toward carbon sequestration, making it an important point for applying soil management practice. The complete transition to a stable high carbon use efficiency state occurs at higher nitrogen levels, close to 1.5, when carbon sequestration becomes dominant. In conclusion, the study demonstrates that a non-equilibrium approach provides a more realistic understanding of soil organic carbon dynamics than traditional equilibrium models. This framework improves the prediction of soil organic carbon accumulation, explains the relationships between microbial carbon use efficiently and carbon sequestration under complex environmental conditions, and offers useful information for sustainable agriculture, soil management, and climate change mitigation. Now I am going to answer the following questions. What is the significance of soil organic carbon in relation to soil health and ecosystem service? Okay, soil organic carbon is essential for soil health because it improves soil quality, increases fertility, supports plant growth, and helps maintain ecosystem service. It also stores carbon in the soil, reducing carbon dioxide in the atmosphere and contributing to climate change mitigation. 2. How did previous studies approach the assessment of soil organic carbon dynamics and what limitation did they encounter? Okay. Previous studies assessed soil organic carbon dynamics by considering microbial system as equilibrium system, their limitation was that they ignored the random environmental fluctuations affecting microorganisms, so they could not fully explain the complex process of carbon accumulation and carbon loss. 3. What novel approach did this study introduce to understand the relationship between microbial carbon use efficiently and soil organic carbon? Okay, this study introduces a non-equilibrium statistical mechanics approach using potential landscape and flux analysis. This new framework allowed the research to study how microbial carbon use efficiency and soil organic carbon change under dynamic environmental conditions and random disturbance. 4. What environmental factor was identified as the most critical influencing carbon use efficiently on a global scale? The research identified nitrogen as the most important environmental factor affecting microbial carbon use efficiency on a global scale. They found that increasing nitrogen generally increases carbon use efficiency and promotes carbon sequestration. 5. According to the study, what nitrogen level is associated with the potential for carbon sequestration and what management actions should be taken. Okay. According to the study, a nitrogen level of 0.5 is associated with the potential for carbon sequestration, and these stage farmers and land managers should apply active soil management practice to improve soil fertility and increase its long-term carbon storage. Now I show you 10 keywords. Thank you for watching.